Welcome. In this little video, we want to support the claim that you can reproduce our study accounts attitudes towards open science in less than 10 minutes. Actually, currently, you also have to reproduce it because the paper is not publicly available yet. It's really a fresh project that we are just developing as we speak. But given that it is a paper on open science and sharing data and code, we thought, well, we might walk the talk and actually make everything available even during the early days of paper development so that you can take a peek. So as you see here, in order to reproduce our work, the easiest approach would be simply to generate a code shared space on GitHub. For that, you need an account. So what you're currently seeing while I'm blubbering away is me setting up a temporary account so that I can actually show you how this would look like for you. If you've never been to GitHub, you never worked on GitHub, you don't care on GitHub, no, not that much. So I just created an account that was pretty straightforward. The capture was doable even for me. Now I've received an identification number so that I can prove my email. So that worked out for a change. Now I have a very fresh GitHub account. So you might wonder, why do you need GitHub to reproduce your work? Technically you don't. You could also reproduce it locally, making sure that you have R installed and all the packages that you need and the tech environment. But this is a hassle actually. This can be really, really annoying. Everybody who is reproducing work where code and data is available can tell you about this. So there is an easier option, and this easier option is easier for the user, not necessarily for the team that actually provides this, but this option allows you to start the reproduction by starting a container in GitHub Codespaces. So GitHub Codespaces is a cloud service that GitHub offers, and mild usage, so if you only use it occasionally, is actually for free. So that's really cool. So what you see here in the background is that we are setting up this Codespace environment, the Codespace container if you want. So that was basically very simply done by clicking on code and then on the tab Codespaces, and then we clicked on build Codespace at main. Main is the main branch of the repository if you want. Now, as you see, this actually takes a while, so that's a good time for you to sit back and relax or grab a coffee. In the meantime, here we lead the documentation. So this is what we just did, right? Now we're waiting patiently. And then after that, there is supposed to be some code environment going up, and we have to run make all in the terminal window. So let's see how that works out. Let's see, it's still going along here. So you see the log files. The log files are a lot of gibberish, right? So relatively complex, even if you know what it's supposed to be doing. So you can't get really too much out of it. So the good thing about this container environment is that you don't have to worry about your local computer. So the local computer is not really affected by this. Instead, everything is being run in the cloud, in your browser. And so this environment sets up think about this like a small virtual computer. And if you're a code developer, so if you're this scientific programmer, you can describe how this code environment should look like, how this little computer should look like, and make sure that it has all the tools and features that it needs to reproduce your code. That's not only good for people that want to reproduce your code, but frankly also for, let's say, your co-author team. Because sometimes you have this, that one person is in charge of developing the code and maintaining the code, and then maybe another co-author wants to take a peek at some point in time. But then it becomes a hassle, right? Because you have to make sure that everything is up on your local computer. Maybe you are a Stata user, but this idiot co-author is using R or whatever, or you're a Python fan. So for this, this is actually really nice because, as you will be seen in a sec, here this environment is simply built with a click, right? So it's not more that you want to have to do, and then after a few minutes you see exactly that. You see here in your browser there is an computing environment going up. And if you are familiar with Visual Studio Code, then maybe the only thing that is confusing here that it is in light and not in dark mode. You see that to the left, you see the folder structure of the repository, so all the files that are in the repository, and in the bottom you see the terminal window. Yeah, so the terminal window, think about this as the command line of your little virtual computer. And you see we're supposed to type make all in the terminal, and this is exactly what we're doing right now. Okay, perfect. Now let's see what happens. You see that the computer starts to work. So essentially what it does, it starts to run R scripts, as you can see. And we would have to wait again, but we can also, in the meantime, of course, take a peek around this wonderful new virtual computer that we have. So for example, here you're seeing that's already rendering the paper. That was fast. But you can also see here these different code lines. And of course, you can look at the code file. So you see here on your left, you have the directory structure. And here, for example, you see the code file that recodes the survey data. So the survey data is raw O3 data first, and then some metadata on the variables that we collected. So the questions and the answering options and so on. And here you see, for example, the raw O3 data. So you can take a look at that. You could also take a look at the variables metadata. So here, for example, I simply show you in the data folder the raw response data from our wonderful survey on open science attitudes of accountants. And you can see it looks like CSV, it looks a little bit messy, and you wonder, wow, the structure is odd. So all these files here, so what is this? What does this file even mean? And for this, we have a README. So the README is a markdown file, a simple table. And here what you see is some information on the O3 file. So it's collected, it's as collected and downloaded from O3, so not changed in any bit. And here you have a link to the documentation of O3 if you want to familiarize yourself a little bit more how these files are structured. So then here you see the rendering part of our paper. Yeah, so in the meantime, actually the code is done, so the paper is already reproduced, right? So after just 7 minutes. Here, for example, you see the file that actually contains the paper itself, right? The text and information on how to render the tables and the figures and all. So this is, by the way, a Quarto. A Quarto is really neat if you are into scientific computing. Because it is independent of the actual software that you're using for your programming bit. So it's designed for Python and R, but it also works for other stuff. And essentially, it allows you to render HTML pages and also PDFs. And this is what it has done for us. It has generated 2 PDFs. The first PDF is a paper. The second PDF is a presentation. So here you have the 2-1, paper and presentation. Let's take a look at the paper. Here we go. Okay, so that's the paper, fresh out of the mill, very first draft, I have to say, very rough, a lot of stupid errors in typing, I bet. And then this paper has just been rendered, right? So now you can read it, you can download it with right-clicking on paper PDF, you could download it to your computer, so it's all yours, right? And you can see here that the paper is not only, of course, containing the main text, but also figures and tables. These figures and tables are rendered on the fly. So these are not, whatever, imported from somewhere. So this is all code-based analysis of the underlying data. So given, that what we feature here is a very simple survey, now the data crunching is not too hard and not too complex, but I think it's still nice to have everything in one place, right? So the raw data is there, the analysis is there, and it's all in this wonderful Quarto file. And here, same thing. So this is, Beamer, as you might have guessed, but still in a Quarto file, and it makes reference to essentially the same table and figure calculations. And this is the presentation that we're currently using to showcase the paper. We start to workshop the paper now, and if you're interested in the paper itself and the findings that we have about our attitudes towards open science, then please, by all means, read it. And if you have ideas and thoughts about it, shoot us an email or open an issue in our wonderful GitHub repository. So we would be super interested in hearing from you. Now, maybe some of you are skeptical and say, maybe the PDF was there all the way. So here it's just a little bit of bit of evidence that the paper is actually being rendered. So here I changed my name, my last name to Temp, because I'm Joe Temp here, GitHub repo, and I'm just running make all again. And so what you can see here, it's actually nice. So the make file that structures the dependencies of this project understands that it only has to re-render the paper and not to rerun the actual analysis or the data preparation steps. So that's cool. And you see here the paper has been re-rendered and it's now being offered by Joachim Temp. So how quickly you can make you can have a new paper now, right? Just change the offers. No, not really. Now this, I think, taken together, it gives you an impression on how to actually reproduce our work, first and foremost. Real quick and efficient, I think. And also, maybe this is interesting for you and your projects. And now, also to show you that this is nothing that puts temporary burden on you. So one thing that I really like about GitHub is it's also easy to have these accounts and also to delete these accounts. While having a GitHub account is really something that most likely you will enjoy also later. If you just wanted to try that out, it's actually also very easy for you to delete the account again. Just go to this hamburger button to the top right, click on settings. Then here you have everything that is related to the configuration of your account, and we can click on account. Then you see this reddish thing, delete your account. Here GitHub wants to make sure that you actually not do this accidentally, so it takes you through some hoops. You have to type the name again of the account, and then you have to type in delete my account, and that's what I'm doing. And then after deleting that account, it's essentially done. Right, so I've done full circle. I created a GitHub account, I reproduced a paper in GitHub Codespaces, and I also deleted my GitHub account again. So perfect, job done, mission accomplished. And it's 11 minutes and running, so not too long, I'd say. So for this, if this was interesting to you, then please, by all means, just code along. That was maybe a little bit quick at first sight, but you can simply skip to the video, as you know, and follow step by step. It shouldn't be too hard, and it should actually work. So that's nice. And if you want to know more about it, or if you're interested in this process or open science and accounting overall, then please, by all means, get in touch. And one way to do this is simply, connect to us on GitHub. In this repository, open an issue, discuss whatever you feel like discussing, and please, if you find the time, read our wonderful paper. It has quite a bit of views on the open science community, voiced by us accountants via the survey that we collected a while ago. Well, that's it. So thanks for watching, and have fun.